Hello guys, and what's up? OuttaSyllabus here, and we finally hit 1000 subscribers. And I feel like we need to celebrate that, right? I still remember how I celebrated in 1000 subscribers in my first channel though. My channel, 1000 subscribers! Now in this channel, it will not be like that. We are gonna build something, and that's my new project. I got myself this new camera. As you can see, what the? Oh, I forgot the battery. There you go. What? Oh, I forgot the lens cap. There you go. What the? It's not clicking.
One eternity later.
Okay. There you go. You can hear the nice music from it. So see, I have a huge interest in photography for many years now, and especially astrophotography, and in that also especially deep sky astrophotography. That means photographing the stars, constellations, nebulae and stuff like that. So as you can see, this is my first photo of the Orion Nebula, clicked about a month ago. Now as you can see, as my first attempt to photograph any deep space thing, and also I'm living in a city where the sky quality is not that good, it turned out pretty okay, I guess. So how you capture these images, you may ask? It's pretty simple. Well, in theory, it is all about long exposure shots and stacking them up. But there is a twist. You might know in night photography, we prefer long exposures. Also to photograph lakes and stuff like that. You know, that creamy thing, soft and delicious water flows. We all prefer long exposures. That means we just set our camera into a tripod and then just carefully press the shutter and set a long exposure time, like 10 seconds, even minutes in some case. That means all the lights coming from that source just gets into your sensor. And the most important thing is that tripod and not touching the camera, because that will induce any shake in your system, and that means it will be sort of motion blurs and stuff like that. So that's case of a long exposure night photography. But in case of astrophotography, that is, we are dealing with stars. We are limited to a certain exposure length. The reason we are limited to a certain exposure length, because our Earth is moving. That's the case. Stars also moves in the sky. So if you just leave your camera for long exposure, probably 10 seconds or so, then you will see star trailing. What is star trailing? The stars will not appear as dots in the sky. They will appear as lines. Not lines. Actually, it will be like a rice grain or something like that. And in star photography or faint nebulae photography or stuff like that, you need to open your shutter for a long time, because you need as much light as possible to hit your sensor. Because in these cameras, any cameras, not these cameras, there is something called signal to noise ratio. So whenever you open your sensor, there will be some signal and there will be some noise. And if you don't capture enough light, then that signal will not be enough and the noise will take over. By that, I mean if you capture less light, then you will get more noise. So you want to capture as much light as possible, and there is only one way to do that. Open your shutter for a long time and let all the beautiful lights from all the nebulae come and hit your camera. So our main culprit is the movement of the Earth, which results in movement of the stars. And we cannot open our shutter for long enough, because the stars will not be stars anymore. They will be like a piece of shit in the sky.
Okay.
So there are devices which can help with this. Those are called star trackers. You know what star trackers do? They just counteract the motion of our Earth. So I wanted to buy one, and I searched them online. Star tracker, let's see what we can get. It's so expensive. What the Only the mount costs 10,000 rupees? It. I'll make my own. So now you know already what we are gonna do with our 1000 subscribers. They're gonna design a star tracker, and which will be insane because this is gonna be hard. Because it is a little fine-tuned piece of equipment which will actually work, or at least I think so. So just stop dreaming and let's get started. By the way, this is gonna be a multi-part video series. As you might know, this is a long project. We need to do a lot of things. So no more talking. Let's get into work. I switched to my bigger and better camera. So the first thing we need to understand is what is the rate by which we have to compensate, and the rate is called sidereal rate.
One sidereal day is not exactly equal to 24 hours. That's where the whole leap year comes into play. So we just collect all those times, that is 1 year is equals to approximately 365 and a 1/4 day. So we all just collect those 1/4 and add into a day in 4 years. That's where the leap year comes into play. But that's where one sidereal day is not exactly equal to 24 hours. It's equal to holy sh. See, this is what I needed. 86,164.0905 seconds. What the f? Do I need to be this precise? Probably that's why here it says 24 hours. 15 degrees per hour. 0.00416 degrees per second. Now I got it. That's why probably those star trackers are so expensive. What?
So, in a nutshell, we have to rotate 15 degrees in 1 hour. That means extremely small in 1 second. So it looks like we will need a stepper motor. And fortunately, I have 2 stepper motors from an old printer. Here are they. And one has this sort of a plastic contraption around it. Probably I will use this one because it has this sort of a screw shaped shaft or I don't know what this thing is called.
What the f? Can't find shit, bro. What the hell? It is called worm gear.
So now you have to understand how to drive this motor. This has 1, 2, 3, 5 wires. As you can see, it has a pesky long number in it. So we'll just Google it to find this data. So as you saw the data sheet, we are in a problem right now because these motors are 24 volt motors and I don't know how to drive them because obviously I cannot drive them using batteries. I mean I can, it will need all my 18650 cells, that is I have 6 18650 cells. So to make 24 volts I have to put them all in series. And also I can do that, but charging them will be a pain in the so have to power it using the wall. Seems like I don't even have a 24 volts adapter. Do you see that? It has 2 voltages with different current capabilities. And it has a plug like this. So like that, we can draw 2 separate voltages from it. But neither of that is 24 volts though. But I think we will try with 16 volts first then. As you have seen in the datasheet itself, this motor has an accuracy, this stepper motor has an accuracy of around 7.5 degrees. That's the angle of rotation of one step. And this thing has 48 steps. So basically 360 degrees. However, 7.5 degree is way bigger than our 0.004167 degrees. So this we have to slow it down even more. For that, I found these two gears. Oh, focus.
Okay.
Here's the first plan. I have these two gears laying around, and the plan is put one of these into this one gear. Oh my god, it's so bad at focusing things. Oh. There you go. What? Focus. There you go. Let's see whether it holds it or not. See, here's the final fan. Disable autofocus then. So, put one of these in this one gear, as this thing is highly efficient in reducing speed, and then we'll be going with some gear ratios. As you can see, if you put this like that, you see the white gear spins a lot slower than the black one. So slow. Slow as And see, I will put the black gear like this with this one gear. So the motor shaft will rotate at speed, and this one gear will reduce the speed down. This black gear will spin slow, and then there will come our white gear right here, which will be like this, and that will spin a lot slower than the black gear itself. Sounds like a decent idea as of now. Oh This is the plan as of now.
Now let's see how to drive them properly.
Day 3.
So, after 2 days of research, as my motor has 5 hours in it, it seems like this is a unipolar motor. Stepper motors can be of 2 types, unipolar and bipolar. So what we have in bipolar, we have 2. So in bipolar stepper motor, we have 2 sets of coils, or 2 pair of coils. So we have 4 wires. But in unipolar stepper motors, what we have in those 2 sets of coils, we have center tap in those 2 coils, and generally the center taps are just shorted together, and we have another wire like this. I have 5 wires in here. See? So one of them will be common, or the center tap of those 2 coils, and the other will be the ends of the 2 coils. So I need to figure out that first. So the good part is, you know what? We can drive unipolar motors as bipolar motors. How, you may ask? So we just ignore the center tap, because the rest of the coils is just perfect. We can just ignore the center tap and take ends of those 2 coils and just drive it using my L293D motor drive. You can drive stepper motors using that, but in bipolar configuration. So you have to ignore the common center tap. We will also have higher torque in that case. So I'm going with that because I don't have any other controller except of these. This is the L29HN motor driver what I used in my this cute little line follower. So you guessed it, I have to dismantle this beauty. But no worries, I will not use the mica and stuff like that. I will just only pick up the Arduino and the L298N. Rest of it will be in place. So let's get started. These all wires are black, so I have to measure across each of these terminals to find out what we have. It seems like we have found that. See, this is one coil which should show 62 ohms. And here's another coil, the second one, which should also show 62. Yes, there we go. We have 62, and then we have the center taps. See, this will be around 32, around 31 at other side of the center tap. There we go. And we have here the center tab of the other coil, which is around 31, and this should be around 31 as well. There we go. I found out the contacts we need. So we will not use the center tab, we will ignore that completely, and we will only use the two heads of the two coils. Then we have 4 contacts. So you will be dealing with 4 pins. So time to take it apart. It seems like I did the wiring too great. I cannot undo it now. There you go. There, we have a pesky, long and fat marker. We'll mark everything so that we don't forget anything. Hey, let's mark that. There we go. There we have our Arduino with the L298N driver. And we don't need to make any connections with them, as everything is connected, as you can see. Now we just have to attach our 2 pair of windings of the stepper motor that we have found out in these terminals. And then we have to upload some code to drive the motors, and we'll test it with the 16 volts and we'll see what it does. Let's do it. The connector in this thing is so small, so let me cut the wires out. There you go. I have the motor wires plugged in my driver. Now we have to provide the 16 volts. But before that we have to remove this jumper. Because I've seen in the manual of this L298N, we need to remove this jumper whenever our input voltage is greater than 12 volts. And I have to supply separate 5 volts through it, which I will do using my Arduino. Because I will connect this onto my computer in here, and this thing can provide 5 volts to the IC. But for the motor here, we will just put an external thing, which I will put through this adapter right here, which is 16 volts, and we'll see what happens. So I found the code online and I have to make certain changes, and it should work pretty good for testing. There we go, there we go. What? Even at 16 volts, this thing is powerful.
As you can see, there is a lot of vibrations and sometimes it's moving back and forth. That is because of the wrong sequence.
Let me switch off autofocus.
So let's correct the sequence and see what we can get. Should be able to reduce the vibrations. Here it is after correcting the sequence.
This thing is strong as I was just checking the torque by holding it right in there and see what happened. I again cut my finger. Piece of shit. Moral of the story: don't do stupid shit. There is still some vibration, and it is heating up quite a bit. What the? So that's why I feel like I have to again check the windings and get the sequence right. That's all for this video, I guess. This is getting long as shit. So I have to correct the sequence, revisit the windings. Probably that can reduce the vibrations quite a bit. And also the heating problem. Don't put your fingers in a warm gear while it is running. And this is Malar, you are watching OuttaSyllabus. And for today, I'm signing off.